Okay, so let's discuss a question from heat exchanger. So basically a counterflow heat exchanger is given where water is flowing, okay, at the inlet temperature is 10 degrees Celsius. It gets heated up and the outlet temperature 80 degrees Celsius. And the counterflow heat exchanger, it's getting heated up by oil, and this was water. Okay, so this is oil where the inlet temperature to the oil, because it's a counterflow heat exchanger, so the oil enters at 230. Okay, means both are not entering at the same, both are not flowing in the same direction, and leave at 160. So this is 160. Okay, now delta T1, which will be used for your LMTD method. I mean, we are using LMTD method here because all the temperatures are given. Remember, when all the temperatures are given, LMTD is the method to be used. Okay, so for heat transfer calculation. Now delta T1 is the difference in the temperature at the left end. So that is the maximum difference. So 160 minus 10, that is 150. Okay, that is 150, and at the right end the delta T2 is the difference, so 230 minus 80, so that is also 150. Yeah, so the delta T's are same. Remember that when delta T1 and delta T2 are same, then it can be proved that the LMTD, which is basically log mean temperature, and it is delta T2 minus delta T1 by ln delta T2 by delta T1. Now this remains, basically this boils down whenever delta T1 is equal to delta T, this becomes delta T1. Now there is a derivation for that. When you derive this LMTD, there is a point when delta T1 is delta T2, this becomes, remember that LMTD becomes delta T1. Okay, so now how do you calculate heat transfer? Now Q is UA delta T LM, or basically this is LMTD, that is UA LMTD. Okay, that's what log mean temperature difference. Now so basically I need to find out the minimum area. I know U and I know LMTD, so but I don't know Q. Now how do I get Q? Now if you take one liquid, okay, the Q is change in the internal energy for any of the liquid, for water or for oil. Okay, so let's take, for water. Okay, so Q, because it will be same, the temperature difference, so this is MC MCV delta T. Okay, for the water, MC delta T is the heat capacity, and heat capacity is given as, both are equal, and the heat capacity is given as 1.31 kilowatts, so into 10 power 3, and change in the temperature of outlet to inlet of the water is 70. That is same for both, so that is 70. So once we get Q, we'll substitute it here. Okay, so Q is 1.31 into 10 power 3 into 70. Now U is given as 420. A is something which we need to calculate. LMTD, it is 150. Remember, it's delta T1, delta T2, it's 150. So if I calculate from this equation area, I would be getting 1.45 meters square. So the area is 1.45 meters square. There is a correction in the options. Okay, so the B will be corrected to 1.45 meters square. So B is the answer. Remember that the answer is 1.45 meters square. So the only catch thing here is that when on the left hand and the right hand, when the temperatures, inlet temperatures, when the temperatures on the one end of water and oil, and temperatures on other end of water and oil, if they are same, that is basically delta T1 and delta T2 is same, then LMTD basically becomes delta T1 or delta T2. Okay, you need not apply the log and all that. Okay, it basically will give 0 by 0, but that's not correct. Okay, so this is a special case. Delta T1 and delta T2 are equal, LMTD is equal to either of them. Okay, so thank you.